right. So we're doing more modeling with equations. So this one is, right, we know modeling. We're turning word problems into math. So we're not doing anything new in terms of the math. We're doing a lot of the same thing from 6.1 and 6.2, but now we're going to specialize in word problems. Okay, so for example 1, find an equation and solve for each of the situations below. Twice the sum of a number and 11 is 4. Find the number. So there's like certain keywords that you want to find, right? Like sum means add. So we're summing two things. And the two things that we are adding together are a number and 11. So we could do n and 11. And we need twice the sum of that. So we're going to put this whole thing in parentheses and put a 2 there. So twice the sum of a number and 11 is 4. Now we need to solve. So this is now just like similar to what we did before. So we're going to distribute. 2n plus 22 equals 4. We distributed that 2. Then we minus 22 from both sides. 2n equals negative 18. And then we divide both sides by 2. We get n equals negative 9. So the hardest part about this one is writing it out, right? Translating this like really bad English to math. Okay, so 6 less than the sum of twice a number and 3 times a number is equal to 39. So that looks gross too, right? Let's just start with our keywords. We know sum, so we know that two things are going to be added together.
Where is this used in real life?
This is used in the next math class you take.
She's not wrong. She's literally not.
Okay, so we have two things added together, twice a number, 2n, and 3 times a number, 3n.
Does it have to be n?
No, you can use any letter.
Okay.
Okay, and so then 6 less than this whole thing. So we're going to do minus 6 equals 39. So let's go back and read it to make sure we have it right. 6 less than the sum of twice a number and 3 times a number is equal to 39. Okay, so now I want you guys to solve it. So try it for a second and then we'll come back and look together. All right, I saw lots of good work. We got to combine like terms. We get 5n minus 6 equals 39. Add 6 on both sides. 5n equals 45, and then finally divide by 5, we get n equals 9. Amazing. All right, now we have a new type of problem called consecutive integers. So consecutive means like right next to each other, right? Like instead of skipping a year, consecutive would be every year. Okay, so the sum of 3 consecutive integers is 153. Find each integer. So what is the unknown value in this situation? What would be a good variable to use for it? So they already gave you a hint over here, but we just want to start with like the first integer, right? So let's say that n, again, you can use any number, but we're just sticking with any variable, right? N equals your first integer. And then the next integer after that would be n plus 1. And then the one after that would be what? N plus 2. So as long as we make a placeholder for the first number, we can reference the next two by using the original letter and just add 1 and then add 2. Okay, so if we want an equation to model this, it says the sum of 3 consecutive integers is 153. So we're adding 3 things together, and it equals 153. And these are each of the things that we're adding together. So we have n plus 1 plus n plus 2. Right, so it's saying integer 1 plus first integer plus second integer plus third integer equals 153. But instead of using 3 different letters, we used 1 letter and then we like added the 1 and 2 to each of them. All right, and so now that we have our equation, we want to solve it. And so we're going to combine like terms. So I want you guys to try to figure out what n is. All right, you guys got that pretty quick? So we're going to combine our like terms. We have 3n's, and then we have 1 plus 2 is 3. And then we just subtract 3 from both sides. 3n equals 150. And then divide by 3. We get n equals 50. One thing that we need to know is the original question said find each integer. So we found the first one, but we also need, right, the actual answer is 50, 51, and 52. So, right, those are consecutive integers. You can add them all up, and it equals 153. So you can always double check your answer. All right, next example. I'm actually wearing 2 Penn State things right now. Okay, Miss Letts loves Penn State. She sets up a store that sells shirts saying Penn State is better than University of Illinois. Suppose Miss Letts had a sale and she took off 1/5 off of every shirt she sold. That encouraged her favorite student to purchase a shirt which cost them $32. What was the original cost of the shirt? So sometimes people like these because it helps, like, it's easier to think of money. Some people don't because they see a fraction and they freak out. So let's write a model for the situation. Let's do T for t-shirt, right? So T equals original
There's a plug right there.
cost of t-shirt. Okay, so I had the original cost of the t-shirt. I took off 1/5 of the cost, and the student ended up paying $32. So we have T minus 1/5 T equals 32. If you don't like fractions, you could also do percentages. Percentages is really common, or decimals is really common with like money. So you could also write it like T minus 1/5 would be 0.2 T equals 32. So this is the same thing.
Oh yeah, that is easy.
Yeah.
Oh.
Okay, so we'll do this one together because it's the fraction one. So when we're subtracting these, we want to combine like terms, but since it's a fraction, we want to make this one into a fraction. So we're going to write this as 5/5t minus 1/5t equals 32. And then remember, when we're subtracting fractions, we need a common denominator. So that's why I made it 5/5. So 5 minus 1, we get 4/5t equals 32. And then we did this with like the grouping. We can multiply both sides by 5. And that will cross out the one on the bottom. We get 4t equals, what is it, 160. And then we divide by 4, we get t equals $40. So if you think about it in terms of like shopping, it makes sense, right? If the shirt was $40, I got 1/5 off, which is $8, then I ended up paying $32. So once you have the answer, usually it's easier to like understand where everything is coming from. And then with fractions, you can just do, right, this would have a little 1 in front. So 1 minus 0.2 would be 0.8t equals 32, right? Sort of like 80% of the original price. Or you could say like a 20% discount. And then you end up getting the same thing. And you can always go back and check. So you always want to check your answer, right? 1/5 of $40 is $8. $8 off is $32 by the time the sale has happened. Okay, we have 2 more examples to do together, and then that is it. Okay, this one we've done before, sort of. This is like rectangles and perimeter. Okay, so whenever I see ones with shapes, I always like to draw it. Okay, so the width of a rectangle is 4 feet less than its length. Find each side of the rectangle if the perimeter equals 162 feet. So we're going to have a model and define the variable. So we already know some information about the width. So let's have like L be length. Right. So we have width is 4 less than length. So length minus 4. And then our length is our length. So we have L minus 4 and L. And now we got to solve it. So for perimeter, we're adding them all up. So we can do like the last unit, like 6.2, where we do distribution. So we have 2L plus 2 times L minus 4. And that equals 168, right? So it's saying I have 2 L's and I have 2 L minus 4s. And I add them all up to get 168. And so now I want you guys to solve for length. All right, a lot of you are there or just about there. So we distribute this 2. We get 2L plus 2L minus 8. Don't forget this negative equals 168. We combine these, so we get 4L minus 8 equals 168. Add 8 to both sides. 4L equals 176. And then you probably need a calculator, but we get L is 44. And we want to always have our units, so it should be 44 feet. And then one thing that you need to remember is we also want each side of the rectangle. So we have our length, and then we need our width. So our width is 4 less. So we have width equals 40 feet. So always remember to check and see what the question is asking for, because sometimes when you solve for the variable, you're not done. Okay, last example. Another money one. Miss Letts wants to sell mini pizzas at lunch to make money for her new strategy club. She is going to sell each pizza for 1/4 more than she bought it for. If a student buys a mini pizza for $6, how much did that mini pizza cost Miss Letts? So we're going to have our model, right? And then have our variable and then solve. So let's say that P is the original cost of the pizza. So I'm selling it for 1/4 more. So I bought it for P, but I'm doing an upcharge of 1/4 P. And by the time the student buys it, that's $6. So P plus 1/4 P equals $6. And so this is similar to the one on the back with the fractions. So see if you can figure out what P is. Okay, so we'll do one with fractions and one with decimals. So P plus 1/4P, that's the same thing as saying 1P plus 1/4P. So this is like 1 1/4 P. If we want to write this in fractions, we go 4/4P plus 1/4P equals 6. And then we can add this. So we get 5/4P equals 6. Then we multiply both sides by 4. We get 5P equals 24. And then we divide by 5. We get P equals 480. If you like decimals better, you can do 1P plus 0.25P equals 6. We combine our like terms. We get 1.25P equals 6. And then divide by 1.25. So it's the same thing. You want to be able to do both, but, you know, if push comes to shove and you have to do one over the other, that's fine, as long as you can do it properly. So I bought it for 480, and then if we divide that by 4 and we add it, right, so if we divide that by 4, it's 120. So 480 plus 120 is $6. So every pizza, I'm like selling it for $1.20 more because I'm trying to make some money for my club. So that is the cost of the pizza. So again, all this stuff, you already know how to do the math. It's just turning the word problems into it. And that's it for this lesson.